Good morning, everybody. We're going to look at our last section today to cover up our statistics section where we are talking about how you describe data sets. And so we're going to be looking at variance and standard deviation today. So the two things that we're going to be looking at are going to be describing the spread of the data. So a couple of things that we've talked about how far your data can stretch, or we've talked about IQR and we've talked about range, and those are good to talk about in certain cases, but they only use two of the data points. So when we want to account for all of the data, what we're going to do is we're going to use standard deviation or we're going to use variance. So variance, what you're talking about is you're talking about how much of a difference there is from the mean. So the way that you calculate variance, so the variable for variance is this sigma squared right here, or this omega squared, excuse me. We've got the summation symbol here. So this just says we're going to add up all of the observations of xi, which is the data point here, your individual data point, and you're going to subtract the mean from every single data point and square it. You're going to add up all of that stuff right here. This sigma is called a summation symbol. So we're going to do data point minus the mean for every single one. We're going to square it, and then we're going to divide it by the amount of occurrences that there are, and then we're going to take the square root of that. Now, for standard deviation, n right here is the number of values. Mu here is the mean. But for standard deviation here, it is simply the square root of variance. So if you took the square root of both sides here, this squared here would cancel out and just give us the variable by itself. We'd have the square root over the summation divided by n. So standard deviation and population variance are all very closely related. So in this course, we will only do the standard deviation and the variance for populations. There's a little bit of a different formula for samples, but we're not worried about that. The only thing that we're worried about is figuring these out for populations. So standard deviation and variance are good for symmetrical data. And what that basically means is data that doesn't have any outliers, standard deviation is very good to use for, because you're using the mean a lot in the formula for standard deviation. You're using that mean up there. And the average we've talked about in class is affected by outliers. So if you have data with a lot of outliers when you're talking about your spread, you may not want to use the standard deviation. If you have more skewed data, you want to trend to use towards the IQR, the percentiles, because that uses more of the middle of the data to talk about that. So you might get a more realistic picture of the spread. So we're going to go over an example of how to calculate the standard deviation and variance by hand, and then we are going to go over an example of how to calculate them using technology, because we do need to see both examples here. So in a nutshell here, I'm going to write the formula for variance. In a nutshell here, all that you have to do to find variance is you have to be able to subtract things, square things, and then multiply them. So we're going to use this data set right here, 3, 12, 8, 15, 7. And we want to know, okay, how far away are these things from the mean? How far are each of these data points away from the mean? Well, the first thing that we've got to do is we've got to get the mean. So we're going to add up 3 plus 12 plus 8 plus 15 plus 7. That looks like it's going to be about 45. And we're dividing it by 5. So our mean here, our mu, is going to be 9. So now what we're going to do is we're going to say, okay, well, here's x. So each of these individual data points we're going to call x. So 3 and 12 and 8 and 15 and 7. So those are just our individual data points. So now when we're calculating x minus the mean, we're calculating the distance from this data point to the mean. So I'm just going to subtract 9 from each of these values. And you could do this all in one step together. It would not matter. Just to run us through it though. So calculating the distance from the mean. 3 minus 9 is negative 6. 12 minus 9 is 3. 8 minus 9 is negative 1. 15 minus 9 is 6. 7 minus 9 is negative 2. So we've calculated that distance from the mean here. And so what we're going to do now is we're going to square it. That will give us a more accurate picture of the distance here. So when we square that distance, we're just going to multiply each of these numbers by itself. So negative 6 squared will give us 36. 3 will give us 9. This will give us 1. 36 again, and then we get 4. So what this says here, so this x minus mu squared, that when we add up all of this stuff together, that's what this sigma right here is going to be equal to. We're adding up all of the data points of xi minus the mean squared. So in this case, if we add all that stuff up, 36 to 36 is 72, 81, 82, 86. That's going to be the value if you add up all of that stuff right there. And so then we're going to get that the population variance here is going to be equal to 86, which is this summation symbol up here, divided by n, which is the amount of terms that we have. So we've found all those distances. We need to find the average distance. So 86 divided by 5 is going to be our answer. So that is roughly, so population variance is going to equal 17.2. That's our population variance right there, 17.2. Now the other one here, the standard deviation, that is simply the square root of variance. That's what we said earlier. So to find the standard deviation, which is another way to talk about that spread, all that we're going to do is we're going to take the square root of this. So if we take the square root of both sides, that's going to cancel out that squared right there. And I don't know the square root of 17.2 off the top of my head. I'm going to use a calculator real quick. It's going to be 4 something, 4.15, give or take. So this right here is our standard deviation, and this right here is our variance. So conceptually, all that we're calculating here is the distance from the mean, and we're squaring it. And then we're going to divide that by how many terms that we have. We're calculating the average distance from the mean, which is another way to describe spread. So then we only have one other example that I want to go over today. And so if you haven't had a chance to, there's a couple of different apps that you all can have for a graphing calculator for virtual learning right now. So the one that I am impartial to, you all can see all my apps right here. The one I'm impartial to is this one right here. Yes, that is PhotoMath. I do like to see what problems I assign are photomathable. So I've got Graph and Calc 83 right here. And if you pull up Graph and Calc 83, let's see if I can back out of this. It just pulls up an old school TI-83 calculator. So what I'm going to show you all here in a second is how to evaluate these on a TI-83. If you have a TI-84 at home, you can use that. It'll work just as fine. If you do not have a graphing calculator at home, this is probably your best option here. So what we're going to do is we're going to be doing number 2 from page 338. We'll answer this real quick using some technology, because finding the standard deviation for this is 26 data points would take forever. So whenever you see this, the expectation is that we do need to know how to calculate it, but when the data gets large, we shouldn't have to do 26 different calculations to figure it out. That's what we have technology for. So Sky recorded the number of pets owned by each student in her class. So we need to know what the standard deviation is here. So I'm going to write down some steps, kind of how to use technology to find this, because that is an important thing that we need to do here. So if you're trying to calculate statistics, if you go to stat here, so I guess I'll write this up here, to find standard deviation. The first thing is if you hit stat here, so we'll say go to stat, and then where it says edit right here, we need to put in a list of values here. So the way that you put in a list of values is all you're going to do is just hit the number and then hit enter, and it will go down. So we need to go stat edit, and we need to put in all of those values. We've got to populate the calculator with a list. So stat edit, punch in values. So then the next thing that we've got to do is say, okay, we've got our values in list 1, which is what L1 is here. So punch in your values to L1. So if you go to stat again, you're going to see an option up here that says calc. So if you hit calc, and if you have an in-person TI-84, just hit the right button to go to calc. And we need to calculate something for this. So what we're going to calculate, we've got one variable here. It's the amount of pets. So we're going to hit one variable statistics, one var stats right here. And if you've only got one list in there, so we'll do stat, go to the right, and then one variable stats, one variable statistics. So then if you hit enter from there, if the only thing you've got in is a list, then it's going to tell you some data here. And the cool thing is, you may not think this is as cool as Mr. Price thinks. You can check your quartiles this way. We've got the min, Q1, median, Q3, max. We've got the mean right there. We've got the summation. We've got the summation of that squared. And what we're looking for here is right here. We've got the standard deviation listed right there. So for this particular problem, we're going to call it 1.59. So we're going to say that standard deviation is equal to approximately 1.59. So moving forward, if you're asked to find that, you are more than welcome to use a calculator to do so. And the same thing for the quartiles. But it is important to know how to do it by hand. We can't just be reliant on calculators to do things, because what if one day we don't have a calculator for something? It's important that we understand how this is done. The thought process of this is very valuable. So then if we've got the standard deviation now, when we're trying to find the population variance of the data here, if population variance is the square root of standard deviation, to go in reverse, what we're going to have to do is say, well, if we're trying to find it if it's this squared, we're going to square this on both sides. So if I do 1.59 squared, I don't know what that is off the top of my head. 1.59 squared, it is 2.5281. So that is our population variance. So as far as notes go, that is all that I've got for today. We're gonna cut down on the amount of work from this section. I do want to take today and kind of review all of the statistics that we've gone over. So I will be assigning some problems from that review set. So if you all have any questions at all, please let me know. Pop in Zoom or shoot me an email, or whatever way you want to get a hold of me. But thanks, y'all.